Hello guys and welcome to my channel. So today I would like to show you how to create lambda functions in Rust. Um, Without further ado, so let's get started. So um, I'm just gonna make a short list here so we kind of like have it at the back of my mind what we'll be working with today. So language wise, like I already said, we'll use Rust for our function. We'll use Rust for our function and we'll use golang to provision our code. And tools, so we would work with Cargo as our package manager. We work with Rust as our compiler. We will work, of course, with the AWS cloud because we'll be deploying our code to the AWS cloud. We'll work with the AWS CDK. Of course, like I said, up there in Go to provision our code in the end to the cloud. And of course, we'll work with Cargo Lambda. This is a library that's gonna really I would really find useful. It's gonna help us like start a new project, and then we can really take off from there. So without further ado, let's jump right in. So let's jump right into it. I think we have everything we need just to cross check. So Cargo Lambda should be installed. Yes, it is. Yeah, so like I said, what I would like to do is to start a new project with the same name as our root folder, because I don't want to, I just want to create this new project and then copy the entire file and then move it back to the same root folder I've created, just because I don't want to do create a new folder, start a new project and then move things around to just not to waste our time. So we can already start a new project. Let's say cargo lambda. I'll give it a name and we'll give it the same name as our root folder just so I can copy everything again. So say Rust lambda. Is this function an HTTP function? We'll say yes, and that's it. So now we have another folder with the same name as our root, because now I want to copy everything in here and move it back to the root and move. And then this folder should now be empty, and now I can actually delete it. And so in source would have our main file, and in here we have packages that are already that this whole thing, or that's actually contains the runtime more or less, is this lambda HTTP. And within this generated code we have a function handler. So basically every of our code regarding this function should live in here within this async function. And then under the main function, of course, which is running behind Tokyo async runtime, this is actually where our function is getting invoked. So we have our tracing subscriber. So if we look in the cargo terminal, we would see we have our lambda HTTP, which is again this guy over here. That's basically how this is working together. And yeah, of course, now we have our Tokyo and tracing subscriber. So these both are basically working in hand to actually kind of like get our logs into CloudWatch. And yeah, that's exactly what is over here. So again, there are a lot of options to actually make some settings regarding what works best for you depending on the project you're working with. And so every code would be writing today would actually live in here within this function. But to actually see if everything works well, we can already test our function. We can do cargo lambda, sorry, not test, starts, I think. Yep, that was correct. So it would run our function locally, and of course it's posted at port 9000. But first it have to build the project and compile it. So if we look into targets, we would have we should be getting a bootstrap folder within which we would see our compiled binaries that would then be, of course, be run by the function locally. And would give it a time, we'll give it a couple of, I don't know, seconds, minutes, I don't know, to actually compile the code, and then we can actually test it. In the meantime, we would be needing, if you've done local development, you might have at some point come across this REST client. I like to read it a lot because it's a lot easier for me to really just work within VS Code, which is my editor of choice, and not having to go to the browser to use other tools or like Regbean as the plugin, or maybe to other tools like Insomnia or Postman, whatever the case may be. So I like to use this a lot, and I just can just come in here and copy this, for example, and then I create a new file. I would give it a name of http. Of the name should be, the ending of the file should be http. I can just paste what I copied in here, and but I would replace this with the supplied URL. And now we can continue. Took quite a while. Anyway, so now we can say cargo lambda start, and this would be listening at port 9000 like we said already, and let's give that a minute to compile for our lambda, which should have exactly new folder called lambda, and then we would have this, like I said before, this is binary called bootstrap. Let's give it a few more seconds or minutes, I don't know, let's see, and we can then test. And we can also test with curl, and this is done. And so right now, the only thing that would happen is that we would hit this function, and yeah, of course, if we have this name query in the URL, then it will be extracted, and we would get hello whatever, say Tony, hello Tony. This is an AWS Lambda HTTP request. But if this is not provided, if there is no such path param the URL, then we would of course unwrap and then use world as a default value. So it would then give us hello world back. This is an AWS HTTP request, and then this is of course the response builder. We get our response back, and that's it, return. So the function signature is also of course interesting, because if you look here, we have a result. We get a result back, which could either be a response with a body or an error. And of course, this error is, we can of course define our own custom error within the application, and then of course maybe channel this through from wherever this error, some error might occur in our application, and then still bring this back here in the front and then return it to the user accordingly. And now we can test our application. We can still use our HTTP REST client. Like I said before, we can send a request and see what happens. Let's test out our application. So maybe we can use curl. So curl HTTP localhost 9000. And then it's Rust lambda, and then we get our response back. Of course, it says hello world, this is an AWS lambda HTTP request. And if we, again, like I said, if you supply a path param, like we say name is equal to Tony, and we get hello Tony, it's an AWS lambda HTTP request. Pretty straightforward. So everything is all set for us to start. And now we can actually get started. Maybe, so what I can also do is from the REST clients, I can put this back in here. I'm gonna say HTTP 1.1, send the requests. It's either request services. Okay, let me try this. Let me put this in here and test it out. And we get our response back. So I don't have time to look into this path parameterization thingy, but you get the point. This is not a problem. This works quite well. What we want to do works. And of course, over here we can, like we did before, supply a path param name and call it Tony, and we get Tony back. So what we would want to do now is to kind of like structure our application in such a way that we could I don't know, for example, say we want to have this lambda function manage some small tiny services in the end. So for me, of course, what I always do is if I have a lambda function, the bigger the lambda tends to get, the more tendency I have to break it down into separate lambdas, because I would, of course, not want to abuse the whole point of using lambdas as a serverless function. So I will always like a lambda function to do one particular thing and then return to the user as fast as possible without actually making the lambda behave like an actual server. That's, I would rather like have a full-blown server for that if I have some computation that's really going to take long. But when it comes to services or microservices, I always have to have them separate on several different lambdas so that they can do several things. Or if they're now maybe start getting bigger and bigger, or maybe if I need them to talk to each other, then maybe I can employ a state machine to orchestrate the whole different lambdas. But the point is just actually just gives you an inner workings of how this could look like for someone trying to get started with this whole thing. So what we can already do is, let's get started. Let's go to, no, I want to be on the screen, so go to main.rs and let's actually restructure the code. So the first thing I might want to do is to, let's just assume that I would like this lambda function to do two things. To allow me access to, let's say, my users in an application, and maybe also to allow me manage groups in an application. And so let's just assume that we can refer to our users and groups as two mini services. Not really big, just assume that. So what we can do is we can actually maybe name this service, and here we say we are expecting a parameter in the URL that says service, and then we say, of course, that I don't know, maybe we say the default would be undefined. And so the point is, what I'm trying to do is I want to be able to say that I want to use something called service that I get from the URL to say know when you want to interact with users or when you want to interact with groups, and while actually having everything under the same exposed endpoint. If I want it to get complex, of course I can then use API gateway to do what I need to do, but let's just keep it as simple as possible. Let's just focus on lambdas here. And yeah, so what we can do is, so now of course our code should break because we don't have who defined anymore. It should be, but that's fine. So who of course is no longer defined, but my IntelliSense is slow unfortunately. But anyways, let's continue. So what we could do is let's not even look at this message for now. So let's just assume that we have, like I said, two services, and inside of within those two services, users and groups, we could have interaction with our users and groups, and we could do things like make posts or gets or deletes, requests, whatever we want to do to these two imaginary services. So what I would want to do is to actually restructure it in such a way that I match this service string over here, and then decide on what to do. So I could say, I could give it a name, and let's say match service, and of course I have, in the end, let's just say I could get users, and I do something with it. I'm not writing Rust, Tony. Yes, I know. Now it's picking up. It's so slow, but it's fine. I say users, and maybe I just print line, and I say service, whatever for now, and we say groups. Thank you. You're waking up. And in the end, of course, if nothing is matched, let's just say for now we didn't understand that you actually could talk to users and groups, we just now match the rest of the possibilities, and then we say something like it is, say service is undefined, and we say service and we put the service in here, right? And so this should be fine now. This would give us like a starting point of what to do. And so we already, yeah, it's fine. We already having this here. Oh, that was a typo. Yeah, so we are matching this service that we are extracting from the URL. And of course here, this is on the fourth server for now, just to silence this dude. We can just name this service. It's still nothing, still broken anyways. This should still be fine. And now what we need to do is to actually define what happens in here. And that's actually where it gets all interesting. So we can, what I would like to do is to, within each of these blocks, to match what should happen depending on the HTTP method is actually coming in from the request. And of course, we have every aspect or every information we need regarding the incoming request from this request object, and we would actually explore that to do what we want to do. So what I would want to do in here, I might start from here, is to now let's say match event, that's method, and here I know it's complaining because I have to match every single method in that enum, but it's fine. Here let's just say I say print line, and let's just say for now I am interested in the gets and in the post and in the delete. So method post, thank you. And let's say I also match method. No, I don't want to. No, let's just keep it simple. Delete, and I match the rest. So every other thing, I will simply print, and that's it. So what I am trying to do, as you can see, is, so let's just assume like if it goes through users and goes through get, in the end we want to return the use to the user, and we could return, say, the HTTP method and maybe some message, or it could be a string or anything, but let's just, in the end, it's still going to be like a kind of like a generic way for each of these methods within these different services. That's, so each method would get back something to the user in the form of, say, the HTTP status code and some message, which for now, let's say, could be a string. And in that case, we could actually already assume that we are getting a tuple from each of these, and each of those tuples, of course, like we said, this is a HTTP method, and the status code. And now we have to take care that each of these our methods actually does what we expect it to do. So for get, yes, complaining a lot, but it's gonna be all right. So for get, let's just return here. Let's just say something like, let's just say something like, maybe let's just say return a string, and we say get, and our status code with, let's just say 200 to 200, right? And we actually just do same for everybody in here. And we, for now, just because of course all the arms of the of our match has to be the same, and when nothing is matched here, we can just maybe return a, say, 4 or 5 something. And this is what the base of our application would look like going forward. So now everything should still be fine. We can try to make the same request one more time and see what we get. So now we are no longer looking for name, but now service. And we could actually say lambda service, and we say user, and this should still be fine. Of course, nothing is really happening in here right now, but you get where we're going with this. And so now I can actually in here, so I would want to make this as generic as possible. So whether you're talking about users or groups, each of them would have methods for now, like say get, post, delete. Let's start with those 3 first. And so what we want to do is, so under the user service, for example, we would want you to be able to do like a post, a get, or a delete, as the case may be. And what we should do now is this, of course, define what should happen when that happens. So, but I would want to make sure, so to make this as generic as possible, each of the methods for each of these different services, let's say, should return a status code and some message string back to the user. And instead of what we have right here, which is this message, we would want that to come from the methods that the user decides to interact with for these different services. So here, let's say that we would, like we said, return a tuple of so let's say HTTP method, and I would say message, and this would get this from, will match the events.method, and so yeah, of course we have to match every arm of the possible methods. So here, okay, so in here you say, like you said, let's just consider sorry, let's just consider posts, get, post, and delete. Get so for now, so when this is matched, for now nothing happens. Let's just match everything. What does this say? A method is not defined. Of course, we have to import the method. So go to lambda HTTP, and here we can import the method. And we have that in here. And now, of course, we said this should return something, HTTP method and a message. So let's get on with it. Now let me do it the other way around. So we have a method, sorry, we have a message. I'm gonna say it's, I'll just call it status code, just to make it straightforward. And in here, sorry, should be HTTP method should be this. Yes. and it should be an enum. Okay, and now here we can actually just return a tuple, and for now this tuple could just be, we'll say, return a new string that says, I don't know, something. And no, of course Tony gets here, so I would say yes, let's just say this is a get, and we have, let's just say 200, not 2300, Tony. And blah blah blah, sorry, Tony should be from. And so we have for get, let's do the same for post, and delete, and this will delete, and we have the last one here. We just, for now, we say everything else, and we can now call this, this would be post delete, and we said, and here we can say unknown for now, and maybe we return a 4 or 5, I don't know. Oh, caps locks on 4 or 5, and of course, as you might have noticed, it's has auto reload, so once you make changes to your code, the changes get reflected right away. Okay, now we have a message string rather, and a status code that we are actually not making use of right now. And so now we could actually in here again actually make the entire service return this message in the end, so we can then use it in our code. So we say this is, we make our service return this, and yes, so here I'll just to be sure, I can just return this one now, just to keep this. And here yes, I can do same. I can do same, and I say maybe 4 or 5, I don't know, and I maybe get rid of this, and so sorry, and now we have our this block of code in the end returning a message and a status code. And why are you complaining? My terms have incompatible arms. Expected unit type found tuple. 1 second. So gets returns this. Okay. Groups. We can just let's keep it, because we would edit this in the end. We can just put this in here also. Sorry, we put this inside a block, and like this, and for our unknown, so for the last part with no services matched, we have match arms of incompatible types. This one to be of time. We are not returning this, which was an error, and we have to return it here as well. And I think it should be fine now. Yes. So we're actually not returning anything here. We're only defining these two variables, and of course with this semicolon, nothing is actually being returned from this block. That's totally fine. That's fair. Okay, so what we now need to do is in here we put our status code, um stat really tiny statute code is in there. And now we have, yeah, of course we can now get rid of this, and this should still be fine. And this is still be fine. So I'll just let me help you out here. Let me do this one more time just to be sure. Okay. I'll give you a minute, buddy. Okay, so it's done compiling. So now we can curl one more time, and we get unknown. One last lambda service. We have service, merchant service. There's this user, or we have user instead of users. So now we say it's get because it's actually a get, so it matches here, and then returns for us. And so this is actually behaving as we would want it to. So now we can top it up a notch. So let's create a folder in here called handler, and I like to go the mod route. So I always like to have a mod.rs, and I would like to have an error .rs where I'm going to define a custom error, and I like to have a module .rs, and I would define services in the service.rs. And in here, I would like to export to the modules error. You're not giving me IntelliSense because in here I'm not using this. Sorry, I'm not using what I defined yet. So that is why you're not giving me. Okay, so in here we can just say mod handler, and now when we type in here we should get IntelliSense, should be fine. So error, and we want to bring in module, and lastly we want to bring in service, and that should be fine. So the next thing I would want to do is to actually, in the main, I want to take this function here and move it to a completely different file. And why am I getting an error? I'm putting error twice. So actually I need to have a file that says main.rs. This will hold the main logic for our handler. So like I said, I would like to move this whole function handler away from the main file. So I'll just copy everything, put it in here, and then sort out the imports. Let's make it as fast as possible. And of course I don't need to do mod handler because you are the mod handler anyways. Permit me to get rid of these comments for now. And so these two I can see are not being used anymore. And what else? That looks okay. And then in our this has to be, of course, have to be exported, so we make it a public function. And so now inside of our main function sorry, I would like to just get rid of the function, and exactly that, I get rid of the function, and now I can import it here again, handler from main, and exactly, of course I don't want to pass, it should be like this. Oh, I missed one closing bracket there. Yeah, should be fine now. So, and now I can clean out these imports. There should be some, I don't know, please, if you know, let me know in the comments if there is some extension I could use that would help me get rid of unused imports automatically. I know Go has it completely baked in, that's you just get it out of the box, but please do let me know if there is something I can always use. Thank you. So just to be sure that things are still working, I can make our same request one more time. It's compiling, it's taking a while. Maybe I just restart it just to be sure. And it takes a while. My PC is getting really slow these days. Okay, let's see. Let's give it a minute or two. It's done. So everything is still fine. So now I'm actually gonna leave this file, which is our main entry point for the Lambda. I'm just gonna get rid of it and start working in here. So this is really what I want to do. Okay. Sorry. So one thing, the first thing I would really want to do is to define some modules, and maybe it would kind of like make you understand like my thought process, and then you can also give your comments. For example, if you think, if you have suggestions or questions or yeah, whatever, just hit me up, please. Like this. Well, I want to hear what you got to say, I think. Anyways, so let's get started. So what first thing I would like to do is to, so if you look in here, you would see that I am expecting that similar things would happen for these two different services we have defined in here. So for now, I'm imagining a scenario whereby you have the possibility to do gets, posts, and deletes. So I want to like kind of like how you would do in other languages, say to define like an interface more or less. I would like to define the module, and then of course on top of that struct define some threads. That's gonna be a little bit more generic, so I can actually use it across services. That's just actually the thought process. So the first thing I would want to do is to define okay, a user module, a user struct. So user model, and it's just gonna have some pretty basic stuff. It's gonna have ID of string. Let's keep it really simple. It's gonna have a name, thank you. It's gonna have thank you. It's gonna have an email, and sorry, and I'm gonna already add some threads. So derive, and I'm gonna add debug, thank you. Now I need clone, I need serialize and deserialize, and I would need to of course install CDK to have these functionalities, and I would have to go get the lookout 1.0. Okay, so let's go to our cargo terminal. In here I would add CD first, and let's say version. It's gonna be no. I want an actual version. I want to say 1.0. Let's see. I should have everything I need. And features. Yeah, of course I need derive. Thank you very much. And I need set the JSON. So version 1.0, and no, I think that's fine. I don't need to specify. It should be cool. Oh, I have it up here already. Yes, nope, no, there's a typo. Okay, so it should be fine like this, and let's rebuild. Or maybe I would need. Let me bring in some UUID. I would need some UUID down the line. So dependence, this is UUID. These are going to be specific for UUID. So the version would be, let me look at docs. Okay, let me do 1.6.1. So features, I'll need v4, need fast range, and finally I will need macro diagnostics. Okay, and I can restart this, so I'll just build some for all. Let's give it some time. Let it build with the new dependencies, and then we can continue. Yes, of course. Okay, I think we are done. And now let's continue. So we need to, of course, import what we have here. So set it and help me out here. Serialize and deserialize. I think that is it. Close that up. So we're good. So that gives us, of course, 3 implementations right away. Okay, so the next thing we would want to do is, like I said, we need to define this thread. That's each of that describes more or less operations that are possible within the services we're working on. And let's define the threads. We can call it I don't know, let's say API methods. So let's say pub threads, API methods, and let's say, of course, this is not necessary because it's there by default. But anyways, what is, oh, Tony, spellings, T-R-A-I-T, pub threads. Oh, sorry. Okay, so let's say I want to have a new method, for example. So the new method maybe takes an ID of a string, and it should return I don't know, it should return so it should return something, an object of a known signature, more or less. So follow me here. I think let me introduce another thread, because I think what's being returned, I need it to be unique, across methods. So this could in the end serve like the data structure, for example, that's would be used as means of passing data, say, across the user service, more or less. So I can define let's define a new thread here. We can call it thank God I spelled it right this time. I can call it service factory. I think let's go with this. And service factory will have one method for now. Let's say, so we can, so this, of course, like I said, will represent the object, and let's just say we need a method that we could use to convert this object to a string. Thank you, that was lovely. So I need to close this out. And so here I would want to now, of course, allocate this on the heap. Allocate this on the heap, and I am not going to make it dynamic. I want this to be known at compile time. Should be fine. Awesome. So that's what this, so any method or any structure that implements this API methods thread, what the new method will be returning would expect it to have a certain structure. Like it could represent whatever the user want to represent in the, or would we as a developer, for example, would need to represent, but in the end we want that object to have a defined signature. That's just the point. That's the thought process here, guys. So we have our get method, for example. Let's say it takes a reference of self, and let's also, I don't know, put this on the heap. And yeah, it also needs to implement. I know there are better ways I can actually do this. Or let's keep going for now. We'll refine along the way. So let's keep these two first. Let's define more. Let's say to have a new, and then you can do a get, and something that says, I don't know, gets whatever that returns. It's not just gonna return this single thingy, but I want it to return a vector of these things, this whatever that has this threat. And let's define a post. So our post would take a payload, which would also be of this form. No, not just to have implement service factory, and we would we will get there. So it takes this and it returns a result. So I don't really expect to get any response back from the post other than a message, you're successful, whatever. And then an error, and let's define a custom error that we want this post to return. But we will come back to this and finish it up anyways. And let's say we want to do a delete as well. Yes, I know it takes 2 arguments. I know I would come back to you. So we'll have a delete that takes a reference to itself and returns also a result. And the results, again, like in post, would be, of course, I don't expect you to give me a payload back in the end, but I would like you to give something back to me that says, okay, you've deleted something. And of course, what this error is just saying that we need something here. So it needs to, of course, it's an enum, it needs to don't have an OK arm and an error arm. And this error, I would like us to define our own custom error. So let's go to errors, that's RS, and what we'll try to do here is we define a struct. It has to be public, of course, so we can import it. I'll call it API error. And no, I don't want no lifetimes for now. And we'll say message should be a string, thank you. And I would like to be able to at least, so okay, let's just import our std error, not error kind. And what I can actually do is come here because I need std fmt. And so one trick, of course, would be to just put this up here and then put fmt here. So we get a one-liner import. And yeah, of course, I would like to add a debug threads. Thank you. Debug. Thank you. And I would like to be able to, because right now we can already use our error inside our modules. We can just maybe use create, and we go to the handler and we go to error, and here we can just pass our error, and we'll pass our API error. Thank you. And we do same here as well. API error, but of course we want to be able to consume, because this error has an attribute called message. We want to be able to, for example, or even, I don't know, log to the standard outputs the entire API error object. So let's implement a debug thread for let's implement a display thread for our error, and then kind of like define how we want this to be displayed to the user. So we import and fmt display for API error. Thank you. That was lovely. So what is it? FMT display. I have to implement the FMT method. I know, of course. FMT. Let's take a reference to self. So let's go self, and yes, formatter. Think this looks almost okay, but the formatter should have of course it takes a lifetime parameter, if I can do that. And thank you. And this should return a result. Of course, that's what we need to have in here. So we have a write. We just basically just pass our message like this. This should be fine. This should be fine. Looks good. And yeah, of course, we need to import error. So just think of it that our struct needs to inherit from the standard error. This is just one way of thinking about it. And for API error, and we just take the default implementations in this thread. That should be fine. That should work for us. So that's our module now has I think the minimum things we need it to have. And yeah, we also need to these are our service factory traits. Sorry, I want to give some space up here. And so our service factory traits, we also need to implement this debug threads on it. So let's make this not display debug. I know, don't complain. I need to implement the FMT method. So it takes us once again self and formatter results, and so I need to also do like I did before, and you should now let's just also say right. What is going on? Why am I no longer it can be really annoying sometimes, to be honest. So this is coming from std, the standard library. Sorry, I think that came out wrong. Yes, this make this dine, and yeah, here as well should be coming from standard library. And okay, and then we use our macro, and then we also I don't know, so I'll just say service factory. Thank you. I don't want to waste so much time on this. So okay, sorry, I named this FMT. Should we have whatever you want to name it anyways. Okay, so we have our API method with these methods, and what they should return looks like more or less. And now what I would like us to do also is to of course now we have, so yes, I like the way I structured this now, because in the end, if this is the object, for example, that would be shared or that would be passed across when these operations are handled, of course it makes a lot of sense that we implement the service factory trait for that struct. Just so we need to basically say what should happen here. That's really the point, guys. So we define a signature, and we say for the objects that we pass across these methods in here. So these threads, loosely speaking, can of course be considered or be compared or likened to interfaces like other languages. I don't know, right? But the point is that we want to be sure that we would want to more or less define the signature of the kind of objects that gets in here, just so we more or less giving us more power, of course, to kind of like define what should happen or not happen. That's really the point. And so we implement for this user model struct, we import the service factory threads for it. Come on, help me. For user model, thank you. And yeah, we have to implement the toString method we defined. And so what we just want to do is to convert this module, this struct, to string, and we can just use setJSON more or less for that. It should do the work. So what we can just do in here is setJSON. Let's say toString, and it is of course reference to self, and we expect a message, and the message should say something like failed to serialize user model object to string, something like that, and that should be fine. And so now we have defined our model. I think that looks okay-ish for now. And maybe one other thing we could also define is to say, let's define something like, I don't know, a response obj. I don't know, something we can decide to give the user in the end. Now we can say response, no, I can keep it really simple, string, and maybe I say some ID is I32, whatever, I don't know. And let's also add like some basic threads. Derive, so we add let's just keep it simple, serialize and deserialize. Do we need debug? We'll find out. I think that should be okay for now. So guys, this will be the end to part 1. So from part 2, we would define the services, we would define what would happen, like regarding the basic HTTP methods we talked about, and then we of course take care of deploying our cloud to the AWS cloud with the help of AWS CDK in Golang. Thank you so much for being part of this journey, and I hope to see you again in the second part of these videos where we can all wrap it all up, test it all out, and see that everything works. Thank you so much, and have a really nice day. Please subscribe, and also of course leave your comments, let me know what you think, and reach out to me if there are questions you would need me to answer. And yeah, until next time, have a nice day, guys. Bye.